So, good morning class. This is Robotics 1, Manipulation and Locomotion. Our first topic for today is about the basic robot operation. And now what are the topics we will discuss about basic robot operation 1. First, about the definition of robot to give an application. It part with the first segment, the power up and shutdown. The second segment, the manual operation. The third segment is the homing. And the fourth segment for basic robot operation is end effector operation. Let's talk about our first objective. So we will launch. So, the basic robot operation and the principles of robotics. The program is loading, and let's mute the audio. Let's talk about the power up and shutdown. And first objective. So, define a robot and give an application. Robot definition. What is a robot? An industrial robot is an automatically controlled, reprogrammable, multi-purpose manipulator and programmable in 3 or more axes. Robots are thought by many people as being very human-like because they are often portrayed in this way in the movies. In some aspects, certain types of robots can move around in a room, and others use artificial intelligence to teach themselves. However, most robots look and act like an industrial machine. And class, there are 3 features that are needed to define a machine as a robot. First, automated. What is automated, guys? So, a robot is an automated if it can operate without the constant control of a human. As you've seen in the monitor, guys, the robots are doing the task of a human without any human control. It has a program, it has already a program, so the robot will know its own designation. So the robot pick the box and place it to another place. So that is the automated feature of our machine robot. They can do without the constant control of a human. So next, reprogrammable. What is reprogrammable, guys? So a robot can be reprogrammed to perform its task in different ways. For example, a CNC machine can cut different shapes in a different piece of metal stock. So, in my opinion, reprogrammable means you can do whatever commands you want to add on in a machine. For example, the CNC machine is a cutting machine for metal, for plastic or anything. CNC can do cutting, and the specification of CNC is to cut a metal. So you can do reprogram it, like you can add on a cutting for heart shape, oblong shape, as long as you want to reprogram. And the last one is able to multitask. What is able to multitask? It can be reprogrammed an entirely different tasks and perform entirely different tasks such as assembly or machine loading. Um, Robots can do multitasking, like you can do two jobs in a row. Like the robot will do the assembly and the robots will do the placing after he after the robot can assemble after the robot assembled the piece. So that's the meaning of multitasking. Not in a human, guys, that once, for example, you are washing the dishes. In an industry, you're washing many kinds of dishes, and you can't do two tasks in a row. Like you're you're you've been assigned to wash the dish, and you'll be going to be assigned to cook. It's not a good thing to do in a real application. That's why the robots are invented to do a multitasking, so they can do different tasks in a row. So many people believe that a robot is a machine capable of being reprogrammed and automated. However, programmable milling machines or a traffic light can be reprogrammed and automated no matter how they are programmed. They still perform only one task: cut metal or turn on lights. The ability to perform different tasks makes a robot different than all other machines. So, robots are used in many different applications: assembly, material handling, welding, machine loading, painting, and gluing. So in a robot, guys, once a robot are been programmed, they can do for example, a robot has a specific job. Um, for example, a welding machine robot, so the robot can do the welding process. Um, he has his own specific designation and do a specific designation with a multitasking operation. So describe three advantages of robots. So robots have a number of advantage over manual labor for performing many tasks. So the first one is improve quality of life. So what is improved quality of life? Robots can work in dangerous, dirty environments where people should not be working. Robots can also perform repetitive tasks that would be boring to human workers. So in robots are designed to do to do a to do a task that the human are not capable of. For example, handling a radioactive materials. Robots are capable of doing that because robots are not are capable of handling radioactive materials that the robot is not a human like are not a human like. For example, the robot is placing a chemical. So the robots are not affected when the chemical are spilled. While human, once the chemical will has been leaked, so the chemical has a bad effect to the human body. So that's the improved quality of life. Robots keep Robots help us to keep away from any form of risk or hazard. Improve quality, the product quality. So, robots perform their tasks very accurately on a consistent basis, causing fewer rejects. They can also perform certain tasks much better than people, such as spray painting. This provides a higher quality in every product. So, in this operation, the robots are consistent with its job. So, he paint, he paint the metal in a consistent and uniform motion. Unlike with human are not capable of doing such thing like that. So in robot, we can lessen our losses, damage item, not not area of the metal has been painted. In robot, there is an accurate result than human. The third one is reduce production cost. What is reduce production cost? So, robots can continuously 24 hours a day, allowing them to produce the quantity of work of 3 people. Also, the multitasking ability of robots means they can reuse if their tasks are no longer needed. Finally, the robot's ability to perform accurately, causing fewer rejects, creates a lower overall cost of production. So in robots, guys, they can do a 24 hours or 24/7 work without any without any without any without any delay. For example, without any delay, they can do a task smoothly. Not unlike for us human, we can only work 8 hours to up to 14 hours. If you exceed 14 hours duty, doing a work like that is not a good for ourselves. We must rest. And robots do not rest. Robots do not rest, guys. Robots are capable of consistent work. So next, describe the 5 basic robot components. So there are 5 main components of a robot: the manipulator, and effector, controller, drives, programming device. So what is manipulator, guys? So the manipulator are also called the arm, is the part of the robot that actually moves and reaches. So as we can see, the manipulator of a robot is the arm that it actually moves and reaches the piece. So next, and effector. The end effector is used to grasp parts of or tools. One type of end effector is the hand or gripper. So after you manipulate, what is the effect? And the effect is to grip or grasp the object. That's the purpose of end effector. Controller. A controller is the specialized machine that coordinates a robot's movements. So in our subject, we will use a controller called Arduino. So we will search in Google what is Arduino. So this is Arduino, guys. This is the controller will be using to our subject, guys. The controller is the brain of our robots. All of our program has been uploaded to the controller, and the controller set the operation so the robot will do its task. So drives, what are drives? Drives are electronic circuit cards in the controller that supply power to the robots or motors. So in this image, this as you see in the picture, this is a small part like a black one. This is the IC, the integrated circuits. These are the drive. So the program is inserted inside this IC or the drives, and the drives makes the designation to go into its path. Like the drives give signal to the motor, or the drives give signal to the LED. That's the purpose of drives. It gives supply or signal to the robot or motors. So the last one, programming device. So a robot programming device such as the teach pendant shown is the interface a robot programmer uses to load programs for the robot to execute, and also to control other robots' function. So this programming device is the software where we can put our program to be uploaded inside our microcontroller. In our subject, we will use an IDE for the Arduino. We will use this Arduino IDE. Arduino.cc. This is the site where you can download this software. So this we will verify. This symbol is to upload. This symbol is for new documents. This symbol is to open the recent documents. And this is to save your codes. So download this Arduino 1.8.19 version so you can upload or decode a program using your microcontroller. So next, so list 8 rules of robot safety. So a robot can be very dangerous because it can change the position of its arm very quickly, which may result in serious injury. Therefore, always practice safety around robots. There are 8 very important robot safety rules to follow. First, remove all obstruction from the robot work area. Second, check for signs of damage to the robot. Third, remove loose fitting, clothing, ties, scarves, sleeves, and etc. Fourth, tie up long hair. 5. Remove the teach pendant from the robot work area. 6. Locate the emergency stop button. 7. Ensure safety glasses are worn by people in the area. 8. Ensure all people are outside the robot work area. So these 8 information is an important matter so you can safely operate a robot, because robots robot is a quick process machine. You can't easily be confident when the robot is in operating time. So you must be careful, class, if you are handling a robot. So describe the operation of 5 types of robot safety devices. So like many other automated machine, guys, robots do not work alone. They work with tooling, fixtures, part feeders, and even other machines. The robot's work area and the equipment within it are called a work cell. So as I've said, for the robot safety, you must have emergency stops, barricades, light curtains, safety mats, signs, and tape. So emergency stops. So operators who work in a robot work area must have access to a device called an emergency, like this one. This device must interrupt power to all aspects of the robot work cell, including external and associated devices. In short, emergency stop button is a main controller to stop all the signal and make the robot inactive. That's the purpose of emergency stop button. Barricades. So physical barriers are used to protect people from robots. So you must build a barrier so the people in the area will know where they can they can so the people will know that the work area are in dangerous for the human. So you must restrict the access to the robot. So this is the physical barrier and this is the robot. So the human will not go across the robot if if he or she will enter the door entrance. So other people in the other side, the back, the front, the left, and the right, are safe. So light curtains. So some factories limit access to the robot work cell using a beam of light. The focused light beams are positioned to form a light grid or curtains. When interrupted by a person entering the guard area, the light curtains like an emergency stop button and stops the robot. So the light curtains is a sensing device, guys. Once the human passes to the light, the robot automatically stops. For the safety of the people who cross a path going to the robot. So the laser curtains are a sensor, a type of sensor that sense an obstruction or it may sense that once the light has been cut off and the other sensor will not detect the other light, so the robots automatically stops. So the fourth one, the safety mats. What is safety mats? So another popular safety measure is the electric safety mats. So in short, guys, um, mats are designed Um, mats are designed with a switch inside that opens when someone steps on them. They can be connected to the robot controller to shut down operation immediately. It's just like a curtains. While curtains is a light sensor, while safety mats is has been placed to the ground. So once you step the mat, the operation will stop. So the robots will stop also. So the signs and tape. So signs and tape, warning signs. That's the root word of sign and tapes. You must put a warning sign, the safety tape. So 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 it must be marked off with black and yellow tape to help direct traffic around the hazardous area. Next. So describe six axes of robot manipulator. So the manipulator or the arm of robot is the part of the robot that actually performs the physical task. A robot's arms a robot's arm is able to move to various positions because it has joints that allow the arm to bend much like a person's arm. So so the joints are called axes. So robot axis movement can be either straight line or rotational. So have you as you see this video, so the the movement of our robot has a as a as a swing to the left and it's a right. For example, what is the movement of our robots? He swing, he do a movement vertical and small rotation of the gripper. So that's the axis of our robots. So most robots have between 3 and 6 axes. These axes are divided into two classes, the body axis and wrist axis. So the purpose of the body axis is to move the end effectors to some point in space. These axes are named for the human counterparts they resemble waist, elbow, shoulder. So the shoulder, the waist, and the elbow. So it is a human-like design. So the human has waist, the human has shoulder, and the human has elbow. Wrist axis. So wrist axis allow the robot to orient its end effector. These axes are named using nautical terms, the yaw, the pitch, and the roll. So yaw is the first one. and the pitch. The second one and the last part of the wrist axis is the roll. The roll means the roll function is to move move the gripper for the robot. The yaw is the positioning. The wrist is the position where the gripper will be gripped easily. So next, describe three types of jog application. Jogging means to move the robot arm manually under power. Jogging is done to position the robot arm. There are three reasons to jog the robot: the start up, teaching, shutdown. So the human start up and the human interface the controller. So this means teaching, and the shutdown means the human stops the robot. That's the jogging means. You can do it manually. Manual control of a human. So describe the functions of a robot teach pendant. So a teach pendant, guys, is a handheld control device that is connected to the robot by an electrical cable. This device is often used to remotely jog the robot. Teach pendants can also be used to teach or program the robot. For example, um, teach pendant is a remote that are not they're not wireless. So there are some robots that are not being controlled automatically. Some robots control it manually. That has a controller like this. So we can say that this is a teach pendant controller, a handheld control. So teach pendants are typically comprised of the following components: digital screen, emergency stop button, and keypad, where you can interface your command. These are some of the most common functions found on a robot teach pendant: the jogging, teaching points, move to teach a point, test inputs and outputs, and running a program. So next, so next, describe the functions of the four components of a servo robot axis. So there are four components of a robot axis, guys, ha? Servo motor. So what is a servo motor? So a servo motor is an electrical motor that is connected by its shaft to the robot's mechanical structure. Servo motors are specifically designed to be able to move the shaft at a specific speed and stop at a precise position under the control of the drives and the robot controller. So guys, there are two types of motor we'll be using in our class. So the servo motor and a DC motor. So what is the difference of servo motor and DC motor? So a servo motor is a geared motor where we can program where can be reprogrammable on what angle we would like to have. Like we will do a program about 30 degrees. You can do it in servo. While in DC, you can't program DC motor on what angle you wanted to do. So this is the common servo motor we will be using while we are having our robotics 1. So servo motor. So this is a servo motor. So as you see in the picture, this is a DC motor, the gear that drives to the motor. So the servo motor is a servo motor has a high torque than the DC motor because DC motor is a direct motor without a gear inside its gearbox. So this is in this blue plastic there is this we called a gearbox. So the main motor is inside the blue plastic or the blue gearbox. So next. So encoder. What is encoder? So the encoder is an electronic device attached to the shaft of the servo motor. The encoder allows the robot controller to continuously monitor the position of the servo motors. It does this by sending a string or electrical pulses at its shaft position is moved by the movement of the motor. The pulses are counted by the controller to define exactly where to stop the monitor. So, encoder is a microchip, guys, where where all the program has been decoded with these microchips, and we will call this as an encoder. So, mechanical structure. What is mechanical structure? The mechanical structure includes the gears, chains, bearings, as well as the physical structure itself. The mechanical structure houses the other components and contains the parts necessary to complete the robot's required task. Home position sensor. So home position sensor are used to reset the encoder values stored in the robot controller whenever the robot is home, and this is important because the controller uses the position where the encoder values are zeroed as reference when it moves the robot. So encoder helps the robots to reset the values stored inside the robot controller. So what is a controller? In general sense, a controller can be thought of as something or someone that interfaces between two systems and manages communication between them. Next. So describe the functions of the homing procedure. So homing or nesting is an automatic procedure that causes the robot axis to move to a position where they actuate the home sensor. The controller then resets its memory for each encoder position to 0. This makes sure that the robot will accurately go to each position stored in memory. So, what is an automatic? Having the ability of starting, operating, or moving independently. So, the robot should always be homed when first turned on because it is operated or programmed. So describe the operation of the homing procedure for a servo robot. So the homing procedure for a servo robot homes each axis in a specific sequence that ensures the robot will not crash into anything. So it will not crash to anything that obstruct the robots. Once the robot moves an axis until it has actuated in home sensor, the robot stops moving that the axis proceeds to the next axis in the homing procedure sequence. The time a homing procedure takes varies with the distance each axis is away from its home position sensor. So this is the waist axis number 1, the shoulder, the shoulder axis number 2, the elbow, the axis number 3, the wrist pitch, axis number 4, the number 3, the wrist roll, the axis number 5. For example, a robot may perform the following homing sequence. First, shoulder axis 2. Second, elbow axis 3. Third, wrist roll axis number 5. Number 4, wrist pitch or axis number 4. The last one, the waist, the axis number 1. So these are the following homing sequence that the robots must do. It first the 1, 2, 3, 4, 5 sequence. The last one who will do his sequence is the number 5, the waist. So shoulder, elbow, wrist roll, wrist pitch, and the last one is waist. So that's the proper movement of our robotic arm. The waist axis, moving the shoulder axis first helps to ensure that the end effector is clear of any obstruction. So shoulder axis is the one to ensure that the end effector is clear of any obstruction. After you pick an object, the number 1, the shoulder axis number 2, would retract so that the object will not be struck by any form of obstruction, guys. So the waist axis is actually homed last. So as I've said, the number 5 is the last one who will be moved for its last sequence. So the robot controller will continue moving the axis until it reaches the home position. This procedure will continue until all axes are in the home position. Describe the function of two types of end effectors. So, there are two types of end effector, guys. So, in order for the robot to perform work, the manipulation must be outfitted with a device called an end effector. The most common type of end effector is a gripper, which can grasp an object and move it. So this is the gripper who grip an object box. So there are two types of end effector. Let's start with end of arm. So, end of arm toolings do not grasp. For example, a robot welding machine. A robot welding machine do not have a hand to hold or grasp. Instead, the robot to perform a specific task on an object such as drilling, welding, or cutting. That's are the possible movement when it has a robot called end of arm. So the robot do not hold. The robot will be doing as such as drilling, welding, or cutting. So list two types of gripper finger designs and describe their operation. So grippers are available with several types of finger designs to allow them to best handle a part at the least cost. There are two common types of gripper, guys. The two-point curvilinear and the two-point parallel. So, two-point curvilinear. Two-point curvilinear grippers have two fingers that close on the part. The closing movement of a curvilinear two-point grippers is a circular path because the fingers are jointed from the single pivot point around which they rotate. So the two-point curvilinear gripper is often pneumatic powered. It's the most common type of gripper used in industry because it is inexpensive and simple design. The fingers on the curvilinear grippers are only parallel with the part in one position. So in one position, the gripper is parallel. So the two-point parallel. So two-point parallel gripper also has two fingers that close on the part, which with this type, however, the fingers do not rotate about a point. Instead, they move in a straight line toward each other with the fingertips. So, straight line, guys. Oh. The gripper is more expensive than the two-point curvilinear gripper. The two-point parallel gripper can pick up a wider range of size. So, mas kusgan si two-point parallel gripper. Because the gripper fingers will close flat on the part no matter how large the part. This type of gripper can pick up many different part sizes because it does not always have to be exactly parallel to pick up the part. So this so we are done to our first topic about basic robot operation, guys. So all the commands